In this JEP Café, you will see Java 17 new features in action, records, switch expressions, and pattern matching for switch, used to solve the Wordle Kata we created with Donald Drab. So let me grab a cup of coffee and we start right now. What is Wordle about? If you already know, please skip this part and jump directly to the live coding section of this video. If you don't know, here are some explanations. There is a hidden 5-letter word that you want to guess, and for that you give a word, and the game tells you for every letter if it is in the word or not, and at the right place or not. So, for instance, if the hidden word you want to guess is siren and your guess is sigma, then you will have the S and the I at the right place. If your guess is sepia, then the S is at the right place, the E and the I are at the wrong place. But if your guess is the word agree, then of course the R is at the right place, and then you have two letters, E, one at the right place and the other one at the wrong place. Well, the one at the right place will take the priority, so it will be flagged as being at the right place, and the other one will not be flagged at all. And the same kind of thing goes for the siege guess, for instance. Here the first E is flagged as being in the wrong place, but the second E, because there is no second E in siren, will not be there. And now suppose that the word you need to find is the word siege, and your guess is jewel. Here in jewel you have two E's, but it turns out that you also have two E's in siege. So it means that each E can be flagged as being at the wrong place. So we talked about this kata with Don on Twitter and found that generating this answer would make a very nice kata. By the way, we also talked about creating a solver in Java using Eclipse Collections and Java 17. Maybe we'll do that for the next kata. So Don created this solution using Eclipse Collections, and he wrote a series of several very interesting blog posts on Medium, link in the description. And because we're having this conversation in public on Twitter, not one but two solutions were also proposed by Vladimir Sakharov, so thank you Vladimir for that. Here they are, you can find the link to this tweet also in the description. So let us see what we can do with the plain API of the JDK 17 using records, switch expressions, and pattern matching for switch. So here we are in the IDE, and here is the first solution Don came with. Let me focus on this part of the code, which is the core of the algorithm. It works in two passes over the letters, which can be natural because you need to favor the right letters over the letters that are not at the right place. And you can see that the first iteration on the letters checks for the right letters. This inject into call loops over the letters of the hidden word and checks if each letter matches the corresponding letter of your guess. If it does not, it adds this letter to the bag called remaining. Then it loops over the letters of your guess, and if there is a match with the hidden word, then the letter is added to the result in uppercase. If it does not, then it is checked for the remaining letters. And here there is a trick, because this remove call returns true if the letter has indeed been removed. So that's two birds with one stone. You first check if the letter is wrongly placed, because this is you get if the letter is in this bag, and remove it at the same time from the remaining letters. If the letter is wrongly placed, it is added in lowercase, and if not, a dot is placed in the result. So you can see that Eclipse Collections has a very powerful method that neither the collection framework nor the Stream API have. So you can do many things with very few lines of code. What about the readability of the code? Well, I'm not sure that it's very clear. You need to understand exactly how these methods are working and know several tricks about this boolean that is returned that tells you if the letter was found or not. Even if this piece of technical code has been put in a method with an explicit name, it's still called replace different position or no match, which is not necessarily super simple to understand. And it defines this parameter remaining that is in fact an algorithm detail. So if you forget this kind of code for a week or two or more and then come back to it, I think that you will need to spend some time understanding how it is working exactly. And performance-wise, well, here they are. We'll need to compare them with the plain JDK solution. Alright, how can we do this with plain Java SE code? Let us first write a working version and see how we can refactor it. So here I wrote some tests that are going to check if our system is able to detect the correctly placed letter between the guess and the hidden word. If I run these tests are going to be read. Of course, this is expected, because for the moment my implementation doesn't do much. How can we do that? Well, we just need in fact to loop over the letters of the guess word. So from I equals 0 to the length of this guess, and I need to compare the letter at the indexed I in the guess with the letter from the hidden word at the same index. And if these letters match, then I'm going to create a result as an empty string, and I'm going to add the uppercase version of this letter, so character.toString, pass this letter as an argument and put it to uppercase. Perfect. And if it doesn't match, then I'm going to add a dot to this result and return the result. The test is green, which is of course expected. This one was really simple. Now let us go back to the test and let us uncomment this. This test will check if we are able to find the letters that are not at the right place, but in a simple case where there is only one such letter. We do not handle collisions right now because collision is a special case and it will need special processing. So we need to add some code in this else branch here, because there we will need to check if the letter we are looking at from the guess word is found in some other place in this hidden word. So let me loop over the letters of the hidden word now, hidden.length, and let me compare now the code point in the guess at I and the code point not at I this time, but on j. And of course, I want to compare this, so there is an if somewhere. I want to compare this only if I is different from j. So if this is the case, now what I want to add is roughly the same as previously, but I don't want to put it in uppercase. And now I run into a first problem, because if I do this correctly and exit the for loop, I will also execute this result plus equal dot. So I need to avoid doing that, and for that what I need to do is add a boolean here. I'm going to call it found, set it to false, and here I found the letter, so I'm going to switch it to true. And so now if this letter has not been found, I can add the result. This is the kind of ugly trick that you are using when you are in this kind of situation where you need to detect that you've done something and you cannot escape this sequence without this boolean. So let me check the tests. And now the tests are green, which is of course expected. We are not quite done yet. What this next test is doing is that it makes sure that we are giving the priority to a well-placed letter over a wrongly placed letters. And unfortunately, this is not the case at the moment, because if I execute this code, I can see that this test is red. So let me go back here. This code is correct, only the letter from the hidden word does not already match a letter from the guess word. So in fact here I need to add another operation, which is that this letter should not match the letter from the guess word at the same position. So guess code point at j. And now if I run this code, the test is green. Okay, we are almost done. There is one last wave of tests to pass, which is this one. which of course does not pass at the moment. And what it does is that it makes sure that a single letter cannot be used twice, whether it is in a guess word or in the hidden word. So let me add some code to implement this. What I want to make sure is that every time a hidden letter is used, it cannot be used again. I have in fact two solutions to do that. Either I make this predicate in this if statement much more complex with another loop to make sure that this is the case. Either every time I check that this hidden letter is used, I remember it by handling an array of Boolean. And by the way, this is what I'm going to do. So I'm going to create an array of Boolean. Let me call it used. This is an array of Boolean which matches the length of the word I'm looking for. And every time I am matching a letter from hidden, I am going to put a true value in this array. So here, used of I is equal to true. And the same here, because here I also have a match with the jth letter from the hidden word. And now, if the letter J has already been used, so used of J is true, then I do not want to execute this if statement, so I'm just going to continue. And once I've found the letter and used the letter J from the hidden word, what I want to do is exit with a break. And now this test should be green. Alright, so we have a solution to the Wordle problem to generate the answer when you give a guess to play Wordle. How is this code working performance-wise? Well, roughly the same as the Eclipse Collections solution. There is no significant difference. How is the readability? To be perfectly honest, I think that this code is just a nightmare. I mean, never ever deliver this kind of code to your application, because you will have to pay for it, or someone will have to pay for it one day or another. Clearly, never do that. So, that being said, how can you fix this kind of code? Well, what you need to understand when you have this kind of code is what makes this code hard to understand. And here there are many things that make it really impossible to understand. There is this loop over the data. There is this array of Boolean. There is another loop in the else part of the if statement. And all this is dealing with two indexes everywhere. You really need to get rid of all this. So let us get rid of all this, because we're not going to use it anymore. Let me remove this. By the way, I'm also going to remove that. And what I'm going to do is say that if in fact guess has a letter at position I that is well placed in hidden, then I'm going to do result plus equal that letter that is guess dot code point at I. I'm going to convert that to a string because I have a two uppercase method on this string class, which is very convenient. And if it's not the case, I'm going to do almost the same. Guess as a letter at position I, which that is not well placed in hidden. And in that case, I am going to do the same apart from the uppercase stuff. And if it's still not the case, then I'm going to add this dot. This code is much more readable, it's much easier to understand, at least the structure is clear. Now we need to make it work. So how can we do that? Well, the first method we need to create is this as a letter at position I. This method, written as it is defined on the string class. Now, how can I add methods on the string class? To do that, I have basically two solutions. The first one is extending the class, which is not possible here because the string class is final, so there is no way I can extend it. And the second one is to wrap it, that is to compose it with another class. And this is what we're going to do, and by the way, this is a very good idea to do that. If you check the introduction of the Gang of 4 pattern book, it is clearly written that you should favor composition over inheritance. So let us do that. We're going to create a special type, a record, that I'm going to call guess. Record guess. And guess what? It's going to be created on this string of character. Now, just to make things easier, this is going to be my guess as string. And I'm going to say that this guess is equal to new guess, and I'm going to wrap this guess as string. And we're not going to use guess as string anymore in this code. Now, this as a letter at position I will be created on this record. And that's a good idea because this is my type. I can do whatever I want with it. I am going to add this length here, and for that create this length method on this record. And this is just plain delegation, super easy. I'm just going to forward this call to this guess string that I'm wrapping. This is the length method that I need. And now I can create this method as a letter at position, and I'm going to call this one index. Right. Now, what do I need to return? I need to return an object, and on this object I will have a method that is well placed in. So this object will also be a record, of course. What is it going to carry as a state? Well, it's going to carry both the guess word, because guess is a word, and the index I'm looking at. So let me call this record guess with index. So this is a guess with index, and I'm going to add this and pass this index as an argument. And I can just add the component of this record in that way. So now what I'm returning is this guess with index. And now I can create this method that is well placed in hidden. I can do the same with this method that is not well placed in. Create it. I will also need this code point on the guess record at index I, and I'm going to forward this call to the string of character I am wrapping. So guess code point at index. Right. Now we are going to proceed step by step. Let us first say that that is well placed should really compare the guess code point at index with the same letter from the hidden word. So hidden code point at index. And now our first group of tests should be green, which is the case. Now you remember that the second group of tests is about checking if one letter is not well placed. So let me loop over the letters of the hidden word. So we need to make the comparison only if index is different from I. If this is true, that is guess code point at index is the same at hidden code point at I, then in that case we need to return true. And this should make our test pass. Great. And now you can see that because we have this return directly in the if statement, we do not need to have this ugly found boolean that was there in the previous version of the code. So now the third step of the code is to favor correctly placed letters over wrongly placed letters. And we did that just by saying that this match can only be taken into account if this letter hidden code point at I does not correspond to a well-placed letter in a guess keyword. So if I run this code for the third step, now the test is also green. And now the last step is a letter from the hidden word should only be used once from the guess word. And for that, you remember that we created this array of boolean. And now things are getting a little tricky because we need to create this array of boolean. We need to somehow attach it to this hidden word, which is a string, so we need to change that, of course, and we need to handle it correctly. So how can we do that? First, this array of boolean is linked somehow to this hidden word, and for the moment this hidden word is just a string, so we need to change that. We are going to make it a hidden keyword equal a new hidden of hidden as string, and this hidden as string will be the component of this record, right? Now we are going to create this as a record hidden on a component that I'm going to call hidden. Of course, there is a bunch of things that does not compile anymore, because this method should now take a hidden object as a parameter. I need this code point at method on hidden. That will return the delegation this hidden code point at index. And I have another one here. It's also hidden there, and I also need to delegate the length method. So now I have properly introduced this hidden record in this code. How can I use it? Well, in fact, when I'm comparing the letter from the guess word to the hidden word, this is where I should be handling this Boolean array. So I'm going to move this code here to the record hidden. So let me put that in a method, and I'm going to call this method match. And in fact, this match method takes two indexes. There is one index for the guess word and one other index for the hidden word. It turns out that these indexes are the same and they are part of the state of the record I am in, but it's still something that this method needs to work properly. So I'm going to call the first one index for guess and the second one index for hidden. And now this method should be called with index. It may look a little weird, but doing that allow me also to say that this line of code there is also a call to this match method. And I'm going to copy this code from here and paste it there. The first index is the right one and the second index is I. I'm going to get rid of this. And now this match method could be moved to this hidden record. So let me do this. I'm going to put this in a variable. I'm going to call it match. And if match is true, then I'm going to say that this used index hidden should be equal to true. If this used index hidden is true, then I need to return false, because it means that this letter from the hidden word has already been used. Now I have a little problem, is that I am in a hidden record and I need to add an instance variable in this record in the form of this used boolean. But if I try to add it just like that, of course I will have a compiler error, so this boolean used here should be really added as a component to this record. And this is the only way you can use to add some state to a record. Now, somewhere else in my code, I am calling a partial constructor on this record, so I need to add this constructor by hand, but this is perfectly legal. I just need to call the canonical constructor of this record, and by the way, I'm going also to initialize this array of booleans, hidden.length. So now, with this piece of code, I am handling the fact that a letter from the hidden word can only be matched once with a guess. And I can see now that my tests are green. Okay, now, can I improve the readability of this code? Can I improve the quality of this code? I think I can. If I check this method, what I can see is that it's basically looping over the letters of the hidden word, and for each letter it evaluates some kind of predicate. This predicate is a little complex, but it's still a predicate. And if for at least one letter there is a match, then it returns true. And if there is no match, then it returns false. Well, it turns out that I have exactly the method I need on a stream API. So I am going to create a stream of integers between 0 and the length of hidden. Okay, and for the elements of this stream, that is for the index on the hidden string of character, I'm going to remove the index that matches index precisely, and then filter the index that matches this. So now that I have only the right index, I can say any match with this one. And that's it. And all the rest can be thrown away. I can return this boolean directly. Are the tests green? Yes, they are. You see that going from a for loop to a stream can greatly improve the quality of your code, can greatly improve the readability of your code. Now what I see is just the core of my algorithm, that is what indexes I'm looking at and what is the match I want to check. And by the way, I can do the same for this code here. This can also be made a stream, the same kind of stream, from 0 to guess.length. Now I do not have any filter. I only have a map to obj because I'm taking integers and returning a string of character. So I'm going to take the I here and copy the block of code that I have there. And now what I need to do is just return every string of character. So now that I have a string of character that I can collect with the collectors.joining, and I can get rid of this. And by the way, this is the result, so this is what I can return directly. I can get rid of this, and of course I should get rid of that. Are my tests still green? Yes, they are, so this code is correct. So this is the first step of our refactoring that really removed most of the technical details of the algorithm. You can see that now the business method that you have is much more easy to read and to understand. In fact, the technical code has been hidden in the records, and we designed this code with the business needs as a starting point, by designing the method we wanted to call and the method we wanted to see. And as we were implementing this method, we just created the record and the methods we were needing on the fly. And once again, if you are concerned by the performances, well, here they are, and as you can see, there is not much to worry about. Now, if you take a look at this code, you may be thinking, this is a switch. And indeed, you are right. Now, how can you move from this code to a code built on a switch? Well, when you have a switch, whether it's a statement or an expression, you need to choose the selector variable that you are going to handle. So this is really an index. Okay, so we are going to call it an index. And what you want to do is make a switch with this index with a special selector variable and a bunch of cases. This selector variable can be several things, but in Java 17 we have a preview feature called pattern matching to switch. And in that case, this switch can be, in fact, a type represented by something that looks like a type. And this type could be, just guess, I'm going to call it check character at position index with hidden. Because this is really what we want to do. We want to check this character against the hidden word. And in that case, we do not have an if statement there. What we will have are switch cases. We have a first case that is well placed. And because this is going to be a letter, I'm going to call it letter. And we are going to return this. And we have a second case, which is, I'm going to call it not well placed, also letter. Let me get rid of this code, and I'm going to return this. And in a case this is absent, it's also a letter because I need to put it in that way, but in fact I'm not going to use this letter because what I'm going to return is just this string of character. Now, how can I make this code compile? This code can compile if I'm using sealed types, another feature of Java 17. This guess check character at position index with hidden should in fact return an object of a sealed type, and I'm going to call it sealed interface letter, because it's really a letter. And I'm going to say that this sealed interface only allows the following type to implement itself, which are well placed, not well placed, and absent. And that's it. And now I'm going to create the records. Well placed. It implements letter. Same for not well placed. And same for absent. Now I have everything in place, so I'm going to be able to implement this method. So let me create this check character at position method in the guess record. For the moment I'm going to say that it returns null. By the way, I could call it guess with index because it's the same kind of object as the one I already created. So this is going to be a new guess with index of this add index. So now what I need to do is to add this with method directly on this guess with index record. It does not return an int because what it does return here is the type of the selector variable I have in my switch. And this type should be letter. So now I need to create the right object implementing this letter interface that is well placed, not well placed, or absent. So this letter is well placed if that is well placed of hidden returns true. Now I have a readability problem because that is well placed is not the right name of the method, but never mind, I will fix that in a minute. So now I can return new well placed. Else if that is not well placed in hidden, and in that case I'm going to return not well placed. And if it's not the case, I'm going to return new absent. I'm going to rename this method because that is well placed is not really readable. I'm going to call it is well placed. And the same for this one. This is going to be called is not well placed. Great. Now I need to work a little on this code because this guess code point at index is not exactly what I need. What I need in fact is letter.codePoint because what I have is just a letter. And the same for here. What I have here is just a letter. So it means that on this record I need a code point component and the same for not well placed. So it means that here well placed should really be called with this dot guess dot at this dot index and the same for here. Is this code working properly? Well, there's only one way to find out, which is running the tests. So let me just do that. Yes, the tests are green, so everything is okay. Now you may be wondering, why not putting this transformation code inside the different records instead of putting it inside the switch? Well, that's precisely why the pattern matching for switch has been added to the JDK, to allow you to add behavior to a class without touching it, without modifying it from the outside. Suppose this interface and these implementations are not in your application, or in part of your application that you cannot touch. Currently, you have two solutions to add behavior to them. First, you can extend them as long as they are not final, and second, you can compose them. Composition requires you to create new types, to delegate some method calls to the object you compose. This is what we just did, for instance, for the length method of the string class at the beginning of this kata. And it works great, there's no problem with that. But in that case, all you need to do is to add one single method. So, is it worth creating a new type just for that? Maybe, maybe not. Let us say that being able to add behavior like that from the outside with a switch is a third way of doing that. And if you're using sealed types, which you could, it makes it safe, because if your switch does not cover all the types permitted by this sealed type, then the compiler will tell you with an error. And it's a very lightweight way of doing things. All your technical code is lying within the same method. Alright, let us do some final cleanup because this code can still be improved. This stream is nice, but it's also a technical detail on how the algorithm is working. So let us get rid of it. By the way, what you have here is also a mapping. So this map to object, I could do it in that way. Say that this index is this stuff. Now it's a simple map because it's from a letter to a string of character. This is a letter, I'm going to call it L, and now I'm just switching on L. So now how can I get rid of this stream for good? Well, what I'm just saying here is that I am checking guess against hidden. And on the result, I want to replace each letter with the following. This is basically what I'm doing there. And I want to return this directly. I don't want to see this collector here anymore. Right, so now how can I do that? Well, this check against is in fact a method of the guess record. And this is nice because I already have that. And in this method, I am going to wrap this stream in another object. So here what I'm doing is just this. Because I am in the guess object, I can get rid of this. And now I can directly return that, but I will face the same kind of problem than the one we've been facing since the beginning of this kata. That is, how can we add the replace each letter with method on an object that is in fact a stream of letters? Well, to add a method on this object, either you extend the stream API, which may prove to be a little complex, but you can also wrap it in another object. So let me do that. This is a letter stream. So let me call this object letter stream. And I'm going to create a record letter stream. Okay, it's created on a stream of letter. Let me call this one stream. I'm going to return this. And now that I have this, I'm going to create this method, which takes a function as a parameter, function that takes a letter and returns a string of character. So let me go back here. This method returns a string. It's called replace each letter with. It takes a function that takes a letter and returns a string of character. And I'm going to call it mapper. And it returns the stream, which is the component of this record, mapped with this mapper and collected with the joining collector. Now this code is compiling properly. Let me run the tests. The tests are green, so everything is fine. So now we got rid of the last technical details, that is the use of this stream. Everything has been hidden in private methods. Only your business actions appear in this code, and because they are there, it's super easy to change them if you need that, and it also makes them much more readable. You know exactly what you're doing in each case. What about performances? Don't worry about that, they are roughly the same. Improving the readability of your code in that way does not hurt your performances. Again, thank you Don for working on this kata. I think we really pushed it quite far away, which really is what katas are all about, so it's just perfect. If you want to see more live coding or if you have some katas you like, we're having this conversation on Twitter. So please join us. And with this, I'm out of coffee, so that's it for today. Talk to you soon.